As we discussed all the way back in chapter 1, oftentimes we're going to need to make sure that we're aware of whether we're working in population or samples. And variance and standard deviation is one of those times when we do need to pay attention. The process and much of the calculation is the same, but there are slight differences. And so if we are going to calculate a variance, we do need to know if we're dealing with population or sample. So far in these videos, we've been just using the population equation for both variance and standard deviation. But here I just want to highlight the differences between the two. So variance for the population is again, you can pause this, see if you can write down the variance and the standard deviation equations for population. And okay, so variance, or sigma squared, is what are we looking for? We're summing up the squared deviations from the population mean. And I'm going to be a little more specific. We're using mu, which tells us it's a population mean. We're also using capital N, right? It's the sample, it's the population number of observations. Okay, and that's simply the variance equation. Down here, sigma is just the square root of the above, right? So x minus mu, again, we're still in population, and dividing by n, the population number of observations. Okay, when we turn to sample, two minor changes. Okay, so we still so everything is very similar here, but just like with the mean, we use slightly different notation to remind ourselves. We're going to use a different notation. So we're going to use s, or different s, an s squared. Okay, so instead of sigma, we'll turn, and sigma is in some sense the Greek s, and so we'll use s squared, and that will be equal to sigma. So the first change here is, well, the first change may be s squared. Second change, we're going to use x minus x bar, right? We don't have a mu in samples. I don't know if I have space to remind ourselves that this is sample. Kind of hidden there. So x minus x bar squared. Okay, so of course we need to use x bar instead of mu because we're in sample. We also, remember, we have n, the lowercase n, instead of the big N. Now the biggest thing to remember is that we can't use just n. We're going to use n minus 1. Okay, and so the variance, the equation changes slightly, and so we'll finish writing down the standard deviation, and then we can talk a little bit more about why this is the case. So same thing here. It's the square root of the above. Okay, so nothing changes in the relationship between variance and standard deviation. So we've changed from sigma and sigma squared to s and s squared. We've changed from the mu to the x bars, right? Because we're in the sample world instead of the population. And then lastly, we've changed that denominator. The way we take kind of the average is no longer in the sample world. It's no longer technically the average, right? We're not dividing by the number of observations. We're dividing by the number of observations minus 1. Now, why do we go through the hassle of having to remember that? Well, it turns out that when we think about sampling, when we think about taking a sample from the population, if we were to use the population equation with the regular n there, we would tend to overestimate the variance and thus the standard deviation. And so dividing by n minus 1 brings us back into line with the variance. We'll be able to discuss this a little more fully later on in the semester when we dig into more about sampling and how we go about that, and some of the deeper issues there. But for now, the understanding as it's a way to correct for a little overestimation, right? Because again, with sampling, we're trying to estimate what's true in the population, and if we don't make this little correction, we tend to have a little bit too big. So in practice, the difference is not often not very big, right? So in our examples, on this blackboard here, we use n's equal to 4 or 5 or 6 just to make the math, or to be able to write out all the math. And in that case, dividing by, if we're going to divide by 5 compared to 4, that is going to make a sizable difference. When you have 1,000 or 10,000 observations, really what we're talking about is dividing by 1,000 versus 999. So if you're working with data and you plug in the wrong one, or if you plug both of them in, you'll see them being very close to each other. But we do want to make sure that we're using the right one, especially when we turn to our testing statistics. Okay, so that's really the only difference between population and sample as far as how we go through the process. The process is the same, right? So we need to find the mean of our sample, which is x bar, which we've done in the past, and then just follow the equation.